Okay, this is the review for geometry, Unit 5 test. I'll get to the actual problems, but before we do those, I want to just do a little review of the the points of concurrency and the special segments that they have. So let's think about our little slogan, crunchy peanut butter. Crunchy peanut butter. Actually, let's make that bigger. Peanut butter is always best on a cold morning. So this is a circumcenter. Circumcenter is the one that comes first, just so you don't get these confused. Centroid comes last. So this is a perpendicular bisector. This is an incenter and is an angle bisector. Angle bisector. This is the orthocenter, and orthocenters deal with altitudes, and centroid is a median. Okay, and then let's think about what they mean. Perpendicular bisector is going to, you have to find the midpoint, and you're going to have a perpendicular line. Well, look, I didn't even draw it through the midpoint. Let's go like that. It's going to be perpendicular, and then like this one would go like this, and then our third side is going to go like that. So if you notice, they don't necessarily go through the vertices. They all meet in the middle somewhere, and I didn't make that triangle very well. At any rate, they have a special segments. The special segments are, if you go to this circumcenter, circumcenter, remember, is a point. The lines are the perpendicular bisectors. And the special segments are, if we go like this to the circumcenter from each of the vertices, that length is the same. And so if you were to take your compass and set it so that the distance is from this vertice to the circumcenter, measure that distance, and then put the bullseye of the compass here, and then draw a circle, it's going to exactly circumscribe that triangle like that, so that those 3 points are the only 3 that hit the circle. Okay, so the vertices to the circumcenter, that distance, it's equidistant to all the vertices. Okay, the incenter of the triangle. The incenter is dealing with angle bisectors. And sorry, my drawings aren't that great. So we are going to, when we construct those, and trust me, I'm just drawing these. We're not really constructing them. When we construct them, we use a compass, right? So the angle bisectors come, and they meet here in the incenter. Always going to be in the inside on that one. Whereas this circumcenter sometimes might be on the outside, depending on where the lines fall. Okay? Now, this has a special segments. Let's see. These angles are going to be congruent. Each angle like that. And I failed to mention that back here. These would be congruent. Your remember, these go through the midpoint. So this would be the same as this. Like that. Okay, now back to the angle bisector, sorry. Angles will be congruent, and then special segments, it's going to be equidistant to the sides of that triangle. And that is the side that's perpendicular, the line that's perpendicular to the side. So if I were to set my compass from the midpoint here to the end and drew a circle, the circle would be inscribed inside the triangle like that. Okay? Orthocenters. Orthocenters deal with altitude. And an altitude is just the line that goes from the vertex and creates a right angle. So it's like the height. So it's not necessarily going to go through a midpoint or anything. It's going to just be a perpendicular line that goes through the height. And so this one would go like that. And so there's your orthocenter. And the orthocenter doesn't really have anything special about it. The only thing you might need to remember is that if you have an angle that starts out as obtuse, your altitude may end up being on the outside because it needs to hook up with this line. We extend the line and come down this way. And same way here, we would extend this line this way to get a right angle here. So altitudes could very likely be on the outside of the original triangle. So it starts at a vertex and straight down for a right angle, and it creates an orthocenter in the middle. And then finally, I'm going to erase this. Finally, we have the centroid, and the centroid deals with medians. Now remember, a median, you find your midpoint, and you find the midpoint just like you would when you're constructing a perpendicular bisector. You would use your compass to find a midpoint, and then once you find the midpoint of each segment, you draw the line to the opposite vertex. So it would go like this, and this one is going to go to this one, and this one is going to go to that one, and there it is. Now it does have some special segments. First of all, the middle point is the center of gravity. It's the central point, the point of balance, if you will. Okay, and then the segments all follow the 2/3 property. That, for example, let's call this A and this B right here. From A, B, and let's call this C in the middle. To AC is 1/3 of the distance, and this one is 2/3 of the distance. So if AC is X, that means that CB is going to be 2X. Okay? So, and if the whole entire distance is 18, we know that AC is going to be 6, and CB is going to be 12. Okay, you with me on that? Now, last thing you want to remember is midsegments. A midsegment would be, I'll just draw us a triangle, and we've found the midpoint of 3 sides, and midsegments connect 2 midpoints together. So this would be a midsegment, and this would be a midsegment, and this would be a midsegment. And it has some special properties as well. Let's say this is 10 and this is 10. This midsegment here, I'll call it AB. AB is going to be exactly half of CD right here. So if CD is 20, this is going to be 10. And let's say this is 4 and this is 4, then midsegment, let's call this E, BE is going to be 4. And then let's say this is 12, 12. Just making up these numbers, so I have no idea if they work. 12, 12, and so this midsegment here, AE, is going to be 12. So it's exactly half of the opposite side. Okay, so that is a midsegment. Okay, so that's that review. Now let's zip through the answers on your review. Okay, 2 sides of a triangle are 4 and 11, and I gave you a little hint on how to do that. To find the low end, we're going to take the high number minus the low number, 11 minus 4, so the low end, it has to be greater than 7, and on the high end, we add these two together, and 11 plus 4 is 15, so it has to be less than 15, okay? Because, look, if this is not more than 7, we have 7 and 4 make 11. You can't get a triangle out of that, because if you have a 4 and a 7 and stretch it the whole way out, it's no way it's going to meet the points of another side that are 11 inches long. One of them would have to be a little bit bigger than 4 or a little bit bigger than 7. It just has to be greater than 7 to be able to match. Okay, so this is the easy way to do it. Take your 2 numbers and subtract to get the low one, add to get the high one. Okay? In an isosceles triangle, each leg has a length of 9. Okay? So the base can be any number that is greater than, well, what's 9 minus 9 is 0. It's got to be bigger than 0 and less than what? 18. 9 plus 9 is 18. Determine if each set of numbers could represent the sides of a triangle. Remember, two sides, your two smaller sides, have to add up and be greater than the third side. So look at this one. 10 plus 20 is 30. Not big enough. 5, 14, and 7. 7 plus 5 is 12, and 12 is not larger than 14. It's not going to work. 6 plus 6 is 12. That is greater than 11, so yes, triangle. 8 and 6 is 14. Yes, it's greater than 10. 9 and 4 is 13. That's a no on that one. And then finally, 1 plus 3 is 4, and 4 is less than 5, so that is not going to work. It needs to be greater than 5. Okay, on the next one, it says, list the angles from smallest to largest. So we know that, based on our hinge property, that the longer the side, the bigger the angle is going to be. So if we look here, the opposite angle, so we look at 3, and it's pointing over here at B. So this is going to be the smallest. Then the next highest number is 5, so this is going to be the middle one. And then which one's going to be the largest? Is going to be C, largest. So, in order from smallest to largest, B, A, C. Okay, next. Solve the inequality for AB plus AC is greater than BC. If I were you, I'd write it down like this, and then fill it in. AB is x plus 3 plus AC, x plus 2, needs to be greater than 3x plus 2. Okay, I'm going to work through this rather quickly. 2x plus 5 is greater than 3x plus 2. Let's say you do something like this. Let's say you subtract 3x. So now you have negative x plus 5 is greater than 2. Now we subtract 5. So we have negative x is greater than negative 3. So we divide by negative 1 on both sides. X is what compared to 3? When you divide by a negative, you got to flip the sign. It's x is less than 3. Now, if I had done this a different way, let's say right here, instead of subtracting 3x, I subtract 2x, minus 2x here, and I get 5 is greater than, x plus 2. And then I subtract 2, and I get 3 is greater than x. Well, if 3 is greater than x, when I flip it, x is going to be less than 3. Same answer, so less than 3. On this one, AB plus AC is greater than BC. AB, 4x minus 2, plus AC, 3x plus 1, is greater than 5x plus 7. So we combine like terms. I'm going to erase some of this. Combine like terms, and we get 7x minus 1. Negative 2 plus 1 is minus 1 is greater than 5x plus 7. Add 1. 7x is greater than 5x plus 8. Subtract 5x. 2x is greater than 8. Divide by 2. X is greater than 4. Okay, next. Okay, it says exactly one value can be determined, and which one is it? Well, let's look. On the left side of this triangle, we have a 5 and a 5, so we know that's a midpoint. And then on the right side, we have a 7 and a 7. We know that's a midpoint. But 6 and 8, not a midpoint. So this right here is a mid-segment because it's connecting two midpoints. And so mid-segments have that special property. You go across and look at the corresponding side, and it's going to be half. So 6 plus 8 is 14. So we know that B is going to be equal to 14 divided by 2, so B equals 7. Bada bing, bada boom. Okay, in a triangle, a perpendicular bisector is what to a side? It is perpendicular. It's perpendicular to a side, that symbol, of the triangle, and it intersects that side at its, where does it intersect? Perpendicular bisector is at a midpoint. In a triangle, an angle bisector divides an angle into two congruent what? Angles, not segments, angles. In a triangle, a median connects a, let's think about it, what's a median? We got a midpoint and it goes up to a vertex. Doesn't matter if it's perpendicular or not. And so a median connects a vertex with the midpoint of the opposite side. Okay? In a triangle, an altitude connects a, what does it connect? Remember, an altitude, let me erase this. Let's just draw one. Here's an altitude. It connects a vertex with the line, oh, okay, no, let me see here. Yeah, it connects a vertex with the line containing the opposite side, and it is what? Perpendicular to that side, or to that line. I fumbled around on my words there a little bit, so connects the vertex and the line with the opposite side. A point on the perpendicular bisector of a segment is equidistant from the segment what? What? Let's see here. It would be to the end points of that segment. Let's draw one up here just so you see that. Here's a triangle. Okay, the perpendicular bisector is going to be like this, and it is equidistant to the end points of this line segment right here. Bada bing, bada boom. Okay, a point on an angle bisector is equidistant from the angle's what? From its sides. Remember, if we did an angle bisector, we know if we go to the perpendicular like that, it's going to be equidistant to the sides. And if it's just an angle that's made up with rays, we would say it's equidistant to the rays. Okay, if this distance from here to here is going to be the same. Okay, now let's do number 15. 15 is a little tricky. Write the equation of a line that contains the altitude of triangle ABC through vertex B. Now remember, an altitude is going to be a line, I'm just going to draw another triangle. An altitude is a line that goes from the vertex down and creates a right angle. Not necessarily at the midpoint, it's just it's a line with a right angle. So let's look at the drawing that we have here. We want it to go from vertex B, so what we're trying to find is the line that goes like this, more or less, and we want to find the equation of the line. Okay, so if we want to find the equation of a line, we've got to know the slope, and we've got to know the y-intercept. So let's think about this. How are we going to know what the slope of this line is? Well, if it's going to make a right angle to AC, we have got to know the slope of AC first. We've got to know the slope of AC, and the slope of AC would be, let's do rise over run and figure it out. We have two beautiful points here at the origin and up here, so it's negative 3 over 5. Now, what's the perpendicular slope? The perpendicular slope is going to be opposite and reciprocal. Is going to be positive, there's the opposite, and 5 over 3, reciprocal. So, now that we know that, there's a couple ways you could do this, but let's do it this way. Let's get point B. This point B has coordinates of 1, 2, 3, 4, negative 4, comma, 1, 2, 3, negative 3. Yes? Actually, no. Let's say no. I went over too far. I looked at the B and not at the point. Look, the point is right here. Here's the point. So it's -3, -3. Okay, so -3, -3. Let's use point slope form. Y minus y1 is equal to the slope times x minus x1. So this is x1 and this is y1. So we say y minus -3 would be y plus 3 is equal to the slope. Here's the slope. We're going to use 5/3 times x minus -3 again. So that would be really x plus 3. So we get y plus 3 equals 5/3 x plus 5. Subtract 3 on both sides. So we get y equals 5/3 x plus 2. And there you are. If you have a point and you have a slope, let's put the 2 there, and it's going to go like that. There's your altitude. Okay, and here's the equation. If you have a point and a slope, use point slope form. Y minus y1 is equal to slope times x minus x1. Okay, let's do number 16. Okay, now on the same triangle, it says write the equation of the median of ABC through vertex A. The median of ABC through vertex A. So if it's going through this vertex, it's got to come down and go through the median of this, the midpoint there. So BC is -3, -3, and C is going to be 5, -3. So let's find out what the midpoint is. Should be obvious, we could count it, but I want to show you, just in case it's not obvious on a test or something. You would take the x's, -3 plus 5, and divide it by 2. So that would be, what, 2/2, which equals 1. And then let's do the y's. -3 plus -3 divided by 2 is -6 divided by 2 is -3. So 1 comma -3 is the midpoint. Now, like I say, we could have just counted that on this one, but if it's a line like this and you've got to find the midpoint, you have got to know how to find it. So it's add up the x's and divide by 2, add up the y's and divide by 2. So we have 1 comma -3 is a point. So that point is going to be right here, and it's going to go through this vertex. So let's see what the slope is of that line, because it's going to come down like this. So the slope is, if we do rise over run, we go down 6, and we go over 6. So we have a slope of -1. 6 over 6, -6 over 6 is -1. So we have a slope of -1. So y, let's use point slope form. Y minus y1 would be y plus 3 is equal to the slope -1 times x minus 1. So y plus 3 equals -x plus 1. Subtract 3. So we get y equals -x minus 2. And this one, when I drew the line, you could kind of see the y-intercept was right there at -2. But I wanted you to see the process, just so you know. If you have a point and you have a slope, use point slope form. Okay, number 17, it says find the value of x. Well, let's see what we can figure out on here. These two add up to 4, and if this is the whole line is 8, that means this is 4, so this has got to be a midpoint. And then this whole side right here is 16, and 4 and 4 is 8, so this has got to be 8, so this has got to be a midpoint. So we know that this right here is going to be half of this. Now let's work backwards a little bit more. Since we know this is 2 and 2, here's a midpoint, here's a midpoint, so we know this is a midsegment as well. And it's going to be half of this. So 4 is half, so that makes this 8. And if 8 is half, that makes this 16. X equals 16. Okay, D, E, and F are midpoints. Okay, and so we want to find the perimeter of D, E, F. So let's look. If A, B equals 20 and D is a midpoint, that means this is 10 and this is 10. And then B, C is 36. So that means if this is a midpoint, this is 18 and this is 18. And AC is 24, so this is 12 and this is 12. And then we know when we connect midpoints, you look at the opposite side and it's going to be half. So this is 12, this side is 18, and this side is 10. We add them up, bada bing, bada boom, bada boom, 40. Okay, now let's try it again with the new measurements. It says AD is 3, BF is 6, and EC is 4. So again, we know that those are all midpoints, and so your opposite sides are going to be exactly half, which is going to be the original number, 6, 3, 4. Add them up, 13. Okay, on number 20, let's put these letters so we can read them. This is A, F, D, C, E, B. FB is 21, and OE is 4. We want to find the lengths of OB and AE. Okay, so OB is this line segment here, and if we know the whole thing is 21, and we know that since we see all these congruent marks here, we know that what we have found is the centroid, and those are all medians, and so the 2/3 rule is going to be in effect. So if FB is 21, then this one's going to be 7, and this one's going to be 14. So OB is equal to 14. And then let's see, what's the other one we need to do? AE. Well, we know if this is 4 and the 2/3 rule is in effect, this one's going to be double that. It's going to be 8. So if this is 8 and this is 4, AE total, remember this is a little tricky because it wants both of them, is equal to 12. Okay, these are your letters to remind you of all our special points of concurrency and what they represent. So, crunchy peanut butter is always best on a cold morning. Let's put the mathematical words on here. We've already reviewed it once, so you should know. In fact, you should be able to do it without my help. Why don't you write them down? Hit pause and do it. Okay, I hope you have written down circumcenters, perpendicular bisector, incenter, angle bisector, orthocenters, altitudes, centroid is median. Okay, we did these in class, but just as a reminder, first you want to establish your points on the ends, set your compass a little bit past the halfway point, and then do an arc from that end and set your bullseye over on this one and do an arc again. And I usually find it's easiest to just turn the paper upside down to do that. Then we want to connect up these 2 points with a nice straight line on their straight edge. And you're always going to label your arcs. This one's 1, this is 2, and then our line was 3. And then you're going to do it again from these 2. You're going to set it a little bit past halfway, then you're going to do an arc, and then you're going to do another arc. You're going to find the midpoint, which is from this point to this point. So we connect those up, and yeah, connect them up, and you're going to start to see this should be near the circumcenter. And I know I'm not doing these to scale, so you know, take it for what it is. Set your compass one more time, a little past halfway. Arc from that end, then you go to this end and do another arc. You get your line that goes through the points. And again, I'm sorry, this is not perfect, but you get your circumcenter. Remember, circumcenter is equidistant from all the vertices. And if I were to take my compass and set it with this as the bullseye and set the distance to one vertice, then I can take that compass and draw a circle, and the circle is just going to go around like this, and exactly circumscribe this triangle. Of course, it's going to look better than that when you use a compass, so there you go. Let's look at the one below it. To do the Incenter, you only need to set your compass on one setting. So I usually set it maybe just like around here at that point, and so you're going to use your compass and you're going to draw an arc. That's number one. Then you take these 2 points and leaving it just the way it is, you're going to draw another arc, and then you're going to do a third arc, one from each of these points. You get this point here, and that's going to be your angle bisector. So without changing the compass setting, you could turn your paper and do it again, and you're going to do an arc. Then you have this point and this point, so you're going to have an arc and a third arc, and the intersection point is going to be your angle bisector. Except I didn't do that very well. Well, you get the gist. Sorry. I'm trying to do this on the iPad. It's hard. And let's remember to always number. This one was number 1, and then this was number 2. Here's number 3, and this was 4. And then we can do one more time. Arc, then we do one arc here, we do another arc here, except it's going to come out better than that, like this. And then you're going to draw straight through, and they should all connect up here in the center. That's the Incenter. We're going to label. Oopsie, I did this backwards. This was 1, this was 2. Now, remember, an Incenter has a special quality of, if you find the perpendicular to each side, it's going to be equidistant. Set your compass to that distance, and when you draw a circle, it's going to circumscribe right inside the triangle. Not like that. It'll look better when you use your compass. Okay, so that's it. I hope you do well on the review and even better on the test tomorrow. Okay, see you in class. Bye. Here's some extra problems if you want to try them.